you become more conscious as you go along and everything else, but don't lose sight of what you're doing constantly. You got to keep your mind on. You can't be thinking about the next job, or like I was telling you earlier, if you're doing some other job over there and they call you to do this, you got to drop that over there, forget about what you were doing over there, and concentrate on what you're doing right now in front of you. Because if you don't, it's going to come back and bite you. I mean, it's there, and I can't say it enough that you just got to be careful with this stuff, folks. Okay, and the fuses and stuff like that. This stuff is very, very basic. Starter contacts and stuff. So if you stick your hands in there, please make sure that you check that there is no voltage on the secondary right here at the bottom side of that breaker, because now you're messing with these contactors, and if it's up at the top over there and you close those contacts, you're toast. You have 480 coming right across there.
We had an incident, well, not an incident, but we had an application down at one of the intakes. Normally your power comes in top of the breaker. Loaded.
A lot of times. Because I don't like to use the word normally, you know.
Well, a lot of the time.
Right.
This one, it came in from the bottom, where line became load and load became line. And it was 1,600 out.
Ooh. So they opened the breaker, thinking that it's dead?
Well, you know, you have to go down and reset this thing when the storm hits.
Okay.
It's no fun by yourself. Because you're back then it was way down in the woods. You know, you're a mile out in the middle of nowhere.
Nowhere, yeah.
You know, no communications.
No assist, nothing but you and the animals out there. That's it.
You and the critters. You hope it don't blow up on you. And this one had a tab on the front of the breaker about that long. Then you took a 6-inch handle and slid over it and had to get down under it to slam it.
GE or Square D?
It was,
Because I know that GE has some of those where you actually do put that, like you're saying, that tongue or that extender and everything on it, because those suckers, because the handle by itself is so short, it's only about 2 inches.
yeah,
And you can't do it like
and then
that.
they had a spring clip that locked onto it. You know, it locked your T-handle on and you had to get down under it.
That sounds like a
I want to
GE.
say that it may have been. They changed it on the
Yeah.
Saturday now, so not a problem.
Yeah, I remember coming across a GE like that, and I said, holy smokes. I said, I'll never get this thing up. And they said, no, there's a handle. And I said, no wonder. And I did. I closed maybe one or two, and everything, but boy, it took forever.
Pain in
You
the
know.
butt.
Oh, yeah. Especially, 1,600. And I was struggling. Actually, I think it was on 800 or something like that I was struggling with.
Yeah.
It was body was big or something
yeah.
like that. Beefy body, and it's heavy. Yeah. I was like, shucks. Here's those sections I was telling you about, those 3-inch sections.
Yeah.
So this would be like A, this would be B. The start of that one would be C. So A, B, C. Meaning that this is, the stabs are going to end up on that third 3 inches or whatever it is. D, and so forth and so on. But each one of them, wherever the bucket goes in. So that's the other thing. Also, once you take the bucket out, you can always close that on there, because you know you're going to, you close the door, you're still going to have that opening on that door and everything else, so that the bus will be exposed. I like that to some degree, but then I don't, because of that very fact that it does have the opening in front of that door, and somebody can still go in there. But in these areas and instances like this, you're normally not going to have people who don't have any business going into it. In hospital or other building facilities, in the water treatment business, you're going to have people that only pertain to the business there. But in other, like hospitals or schools, something like that, you're going to have janitors, you're going to have plumbers, you're going to have electricians and stuff like that. So you're going to have people that really have no business and stuff like that, more or less have access to those rooms, or that equipment is located in areas where there's other people that are not qualified to work on this, that are actually going to be in the vicinity of that equipment. That's what I don't like about it. And this, along like the I-line and master packs and stuff like that, were designed at the time when they were, we were doing this, that you could actually take this with the because the bus being energized, right? Your main is closed, so you got everything energized at the top, and so your horizontal buses, along with the vertical buses, are energized. So it made it where you could take once you disconnected, of course, make sure the breaker or your disconnect was open, and you checked it, you take your T leads off, you take all that stuff, and you'd be able to pull it out. Well, because of the incidents and stuff that have happened and the faults that have occurred, because once again, it hadn't really happened to us as far as factory reps, but we were getting so many, and I don't say so many because it was a few, but one was too many incidents where customers were putting them back in there energized. So with the equipment, but then the problems that I was telling you about that have occurred have really occurred, and that's the causes of it and everything else. With the I-line, it was the same thing. The I-line breaker was designed to be able to turn the breaker off, disconnect your cables, pull the breaker while you still had the I-line was hot,
Yeah.
and replace that bad breaker, whatever it was, you know. So with really no downtime. But unfortunately, how they do it, I don't know how they did it. But contractors, and as a matter of fact, this one happened in Corpus Christi at a one of these rec centers or something like that, like the Staples Center or something like that, you know. So they actually ended up, the breaker had gone bad, or it tripped, or was tripping, so they replaced it with a new one. When they went to stick the new one in there, they went face to face. I don't know how they did it or what they did, but you know, it
Wasn't
just
pretty either way.
no, he got hurt. He got hurt pretty bad, and we had to end up replacing the whole I-line section because it blew it out. It melted the daylights out of one of the faces and everything else where it had gone with the other one. So the whole internal guts of that I-line had to be replaced. That's why we don't, you know, we discourage people from, we talk about, and I said, we as the manufacturers are prohibited from working on any energized equipment at all, or breaking the plane. Our hand cannot break the plane of energized equipment unless we're dressed up for it and we have the proper PPE for it and stuff like that. If we're doing troubleshooting as far as in a control power section, stuff like the other, even though it's 120, we have to do an arc flash analysis to make sure that we have the proper PPE, proper rated equipment before we start working on anything or sticking our hands into it. Because if I go in there like this with a screwdriver or everything else and I haven't even done an arc flash analysis, it's terms for termination and stuff. So if we, the manufacturers, take that kind of approach to it, then the customers, well, that's what we try to stress, is you guys should be taking that, if not even more precautions and everything else, because while our level of expertise is, you know, we work on it, and we work on it more, and not necessarily on a daily basis, but we work on it more than you guys do, because you're not going to be working on it that often. So that's one of the things that we just want to stress, that you guys just, you know, take it to heart what we're talking about here. Okay?
Be safe.
Yes, sir. Be safe. Continuously be safe. The installation test here, the same thing. Once again, you do a measure, you know, 5 to 1,000. Take the readings face to face, face to ground. Make sure that all your branch circuits, like it's saying, disconnected. What it's saying here, be on. Make sure that the main disconnects will be off during the installation test. You can also, you know, when you do that, you can actually be checking your wiring back all the way to your disconnects and stuff like that or the other. So there's several ways of doing that. Okay. Once again, this one says that readings should be between 5 to 20 megohm range. If it's been in operation for 48 hours, but more than anything else, it's always 1 megohm during startup. 5 megs after if you had it running before and now you're going back and re-energizing. Maintenance after a fault has occurred. I'm not even going to go there because we already talked about maintenance after fault, maintenance after water damage, because that's exactly what it's going to do, the same thing. You're going to examine the enclosure, everything. It's the same thing. Bus bars, check everything, inspect for cracks, burn marks. You're going to replace anything that had any kind of a pitting or that looks burnt or whatever. A lot of people think that just because there's a pit or a nick on busing or something like that, the other, or a current carrying conductor, that it's okay to use it, you can file it down and say, okay, it's good. But in all reality, the truth of the matter is that current does not flow through a conductor, it actually it's on the skin of it. And when they rate this stuff, it's rated for a certain value because of the surface area. Okay? So if you stop and think about it, and it only makes sense, it's like let's say a watermelon straight across there. You have a certain surface area, but the minute you put a melon scoop and everything else, and you take a nip or dip out of this, it's no longer the same, right? Well, when it comes to the surface area of the bus and stuff like that, it's basically the same thing. It's rated, let's say, at 100 amps, and you take, and there's a gouge, and I mean as far as like after a fault, with a melting point and everything else, where that divot is in there, right? Then it's no longer at 100 amps rated, it's probably 999 or 99.999 or something like that, but it's no longer the 100 amps. It's no different than a number 10 wire, okay, that's rated for, and I know it's not 10 amps, I know it's more like 30, but let's say 10 amps, number 10 wire, 10 amps, and there's one strand missing, you know, it's got 10 strands, one strand of that 10 amp wire missing, it's no longer rated for 10 amps, because you no longer have the 10 strands. There's one strand per amp. You only have now 9 strands, so basically it's the same thing here. When you have a little divot in your you know, due to corrosion, corrosion or whatever, any pitting, that surface area is gone, so it's no longer there. So that rating is no longer what it is, so it has to be replaced. So take that to mind when you see that. Don't think that you can just go in there and, you know, varnish it off or this, that, or the other, and it's, you know, no, it's got to be replaced. Okay? That's after a fault, and then you do your installation test. Your troubleshooting is there again as well. Okay? Got about 4 pages of that. Okay, that takes care of that one. And that's that power meter, which we already covered.
Right.
Okay? So we can actually go out in the field now, and I will cover the other stuff out in the field that was out there. When y'all come back, you can do that survey, or you can do it now and just turn it in over here, whichever, it's up to you. We'll in the open position. Now this I haven't seen, and now back here it's got controls. I know that would be. You can look at it here and open up here. I always said before you do anything, if you read, you'll learn a lot. I hadn't really seen this myself. Just by looking at it, I can try to figure things out. Knowing that it's got a racking handle there, meaning I have to open this to be able to put a racking handle to charge or something or the other, to be able to press a button, open or close or whatever, right? And then I read on here and it says, opening this door prevents electrical operation. Keep door solidly closed. So I figured, okay, if I open this and anything, I might be opening the darn switch and everything else, so you don't want to be opening stuff that you're not aware of, because I'm not sure exactly how this works, but I know for the fact that I see that it's closed, okay? So this is a little bit, even though it's an HBL, like I was telling you, there's different types of HBLs we have as far as for the application. So this one's a little bit different than this one. This is cut and dry. Just pull the handle down, and you can able to see the blade and everything else disconnect from there. Those little, you see those arc chutes? There's a blade there that actually stays, it's kind of spring loaded, and it stays there until the main contact clears far enough so the arcing, so it kind of keeps a contact with the, so you know, it's kind of bleeding to when the main blades come out here, then that little blade snaps out of there quickly. So there's no arc at all between the main and the stationary blade. So the actual moving blade. We didn't cover that, like I said, it wasn't there, but it's very cut right. This is a manual one. And this one again is independent. When you close it, it's that spring. It's going to push it over and everything else. So it's not dependent on how fast you close it. It's charged and going to close itself. and it opens the same way. Now the thing that could bind it has a lot to do with your maintenance, so as far as grease and lubricant and on the spring itself. And of course the pivot points on the blades that move it, and that's what you want to make sure they're always clean. So in their fuse, probably information is on here, rated at 3.3 or 5 or whatever it is, and then probably 200 amp fuse or something in there. Any questions? You don't pull that handle unless you've done the analysis to find out, because if something happens, that window can blow off there. Once this is open, of course you've got all bolts there, which is good. Everything is bolted down, and that's good. And that's one thing that you always want to make sure. So this condition of the equipment is good. You don't see really any scratches or anything like the others, so that's great. Looks like they've done some external maintenance or trying to clean it up a little bit, because you can see how it's, you know, they've done some wiping there and everything else. You've got to be careful that they don't spray stuff that's going to go to the current carrying conductors once again, because any kind of liquid or moisture, I should say, water on current carrying conductors is going to cause erosion of pavement some type of. Okay? You don't. This one's locked. Okay? So remember, you can't open these with them being hot. You can try, but it won't open. Right. This one's locked up. This is open position. You're able to. That's what it looks like. Remember? That we're talking about as far as the truck and everything.
Oh, okay.
You pull the handle down.
Unplugged it.
It unplugs it. You write it out. Of course, they got those to cover that stuff and everything on it. But then you pull it out. See, I've never broken the plane of this equipment and everything. I was able to pull it out like that. It's already been opened, locked out. So I knew that yesterday as well. So I'm okay here and everything else. The only thing is you got to remember is that on the line side, so over here, because the switch is open, remember, so that disconnecting means is open. So there's this side of those fuse clips are not hot, should not be hot. And I said, should not be. I said, you heard me correct myself. I said, are not. I said, should not be hot. So without a voltage sensing device, something like that, I'm not sticking my hand anywhere in there like that, you know, because I don't know for a fact. But the fuses here are a little bit different. You notice these are like, there's going to be like those ceramic fuses that are in the 480, because it's like 2 per phase here. I didn't see that. I hadn't seen that before. That's something new. So, but it goes directly up there, and you basically do the same thing. You'll notice the difference. You know, wondering, the older gentleman that was sitting to my left, I can't remember. Yeah. He was saying, he asked yesterday why the twisting motion and everything else. It's the easy, you know, because when you twist it and pull it towards you, it's easier to pull out that fuse clip than trying to yank it. You can probably go ahead and do it and power it like that. But you can't do it from the middle because you don't have enough oomph on there. So you grab it at the bottom, twist and turn and pull out. And when you insert it, you do the same thing. But remember, you're probably going to have to take, on this, you got a little bit more room. You might be able to work around the C phase was blown, to try to, you know, take out, you know, A beam to get to it because of the way it is. But if it's that last fuse over here in that corner, as far as C phase is concerned, you're not going to be able to do that. You're going to have to take some of those fuses out of there unless you stick your head in there. But, because it's going to be a little mother trying to get a lot of, you can see the clearance at the top. Fuse is going to go in there about that far. So you have to force it, you know, push it in there. And then to be able to get it to the bottom, so you have to use a little power or things. Because it's not open there like it is on the bottom, you got these slits there to get it out. And the ones on the back, if it's C phase, you're going to have to come this way to be able to pull it out if you don't take those out of there. See what I'm getting at? So it's, you have to work with it. And see, this is really light. You can go ahead and feel it. So you'll be able to take that.
Set it off track.
Yeah, that's what I was getting at. But you can set it off track right there. And you can actually take it. You take it completely out of there. See? That's the beauty of this. Put it back on the track. Make sure it's on the track. It's on the track. Set it right there. This actually pushes it back into place. See how it guides on it? Back is connected. Okay? This is actually only 3 instead of the 8. But the concept's the same. See, this is what I was talking about in here. How this thing latches.
Oh,
When it drops in. So you have a heck of a time. It'll come down. Here, you can see it on this one, or that one right there. See
Yeah.
that? So it latches it up. So these doors are not like the 480 doors, a little bit different. Did you see the gauge on this thing, Tim?
yeah.
That's pretty sturdy. Now, that's the same type of gauge steel that was on that door that you saw in that film that was bowed out. Imagine the force to bow those things out like that. That's that potential behind that you got to be careful with. Because this is hot. So all of this is hot right now because they're tied together from the looks of it. They could be separate. Your prints alone would tell you that. But I'm going to make the assumption that for the sake of this idea, they come in with one input and they tie all 4 of these together, and then they individually feed. You got 4 different feeds here. High service pump, 1, 2, 3, and 4. Would only make sense to come in with one and then be able to feed each individual one out there. There's our multi-limb motor controls for each one. That one has the CPAM that I was telling you about.
Yeah, this is transformer.
Okay, which is a little bit different because that would be more like for transformers and everything as far as that CPAM 20, T20, or T23. So T20, T23, 40s, 60s, 80s, and they're all different ones, different types for different applications and stuff like that. But it's, once again, very simple in this also. You can get the information of the book from, you go to squirty.com and download the literature, go in there as far as big and voltage stuff like that, and then type in CPAP, come up with the T20 fit, and you'll get the instruction book with it. And that's the same thing for any one of these pieces of equipment as well. It's closed. You cannot open, and that's the whole deal. That's the open to lock out and everything else, so you can't do that. Then it's a little bit different with this one, when it's, and once again, all of that has to be done in accordance with, now these are a little bit different. See that, I couldn't remember which ones we had here, because this being the motor pack center, it shows you the steps and instructions as far as how to lock it out. This is the other thing we were discussing as far as the colors, as far as red and green. You know, here green is off and red is